The Taiwan Strait is 180 kilometers wide at its narrowest point. That measurement means nothing to a sailor standing watch on the bridge wing of USS Ronald Reagan at 2:54 a.m., watching the phosphorescent churn of the bow wave in the black water below, and listening to the low, continuous hum of a carrier conducting flight operations in a contested environment. To that sailor, the strait is not a distance. It is a condition, a compressed, electrically charged operational space where every radar emission, every communication burst, every heat signature from the flight deck is being tracked, cataloged, and fed into targeting systems on the mainland coast that are close enough on the scale of modern anti-ship weapons to be effectively adjacent. The carrier strike group had been operating in the strait for 71 hours. The deployment was deliberate, visible, and by design. A signal transmitted not in words, but in steel. 100,000 tons of American naval power threading the waterway between the mainland and the island in direct, unhurried assertion of freedom of navigation. The political decision that placed the Reagan in the strait had been made at the highest levels of the U.S. government. The military execution of that decision had fallen to the crew of 5,400 sailors who had been living at an elevated readiness posture since the group crossed the Luzon Strait 4 days earlier, and the electronic environment around them had begun to change in ways that the intelligence teams aboard recognized as preparation rather than observation. The People's Liberation Army Rocket Force had been watching the Reagan's track for 58 hours. That watch had not been passive. The over-the-horizon radar installations along the Fujian coast had been painting the carrier group at regular intervals, feeding positional data into a targeting architecture that had been specifically designed and incrementally refined over 2 decades for the single purpose of placing a warhead on a moving aircraft carrier at ranges that would keep the launch platforms beyond effective U.S. Navy response. The intelligence teams aboard the Reagan had been watching the watching, tracking the radar emissions, cataloging the electronic signatures of the targeting systems, building a picture of the threat that was as complete as any picture they had ever assembled, and that still contained uncertainties whose magnitude they could not precisely quantify. The terminal maneuver capability of the DF-21D's re-entry vehicle was the largest of those uncertainties. The technical intelligence community had a range estimate. The range estimate had error bars. In the next 20 minutes, the actual performance of the weapon would resolve those error bars in the most direct possible way. The carrier strike group had been structured for exactly this environment. The escort screen was positioned in a layered defensive formation that maximized the engagement opportunities for the SM-3 interceptors, while keeping the cruiser and destroyers close enough to the Reagan to provide terminal defense coverage. Every ship in the group had been running modified watch schedules for 60 hours, weighting the combat systems teams toward the threat axis and pulling personnel from non-essential functions to keep the engagement chains fully manned. The crew of the Reagan had been briefed on the DF-21D threat profile during their pre-deployment workup 8 months earlier in San Diego. They had exercised against simulated maneuvering re-entry vehicle profiles in the Pacific training ranges. The exercise outcomes had been good. Exercise outcomes and combat outcomes share a relationship that experienced naval officers describe, consistently and without irony, as motivating rather than predictive. The DF-21D, the weapon that Chinese military planners had spent 20 years developing, refining, and publicly describing as a carrier-specific deterrent, is a ballistic missile that does not behave like a ballistic missile in its terminal phase. It launches like one, a vertical departure from a mobile transporter erector launcher, a boost phase that carries the re-entry vehicle to altitudes where the curvature of the Earth becomes relevant to the engagement geometry. A mid-course phase guided by satellite navigation and data link updates from over-the-horizon radar systems positioned along the Fujian coastline. But in the terminal phase, in the final 90 seconds of a flight that has covered hundreds of kilometers, the re-entry vehicle maneuvers. It receives targeting updates from a combination of radar and passive electronic intelligence sensors, and it adjusts its trajectory with the kind of precision that conventional ballistic missiles cannot achieve. The Aegis system aboard the Reagan's escort screen was designed to engage ballistic threats. It had never engaged a maneuvering re-entry vehicle in actual combat. No ship in the U.S. Navy had. At 2:54 a.m., the E-2D Hawkeye on the outer surveillance track detected the launch signatures. Not one, not two. 6 simultaneous thermal events along a 200-kilometer stretch of the Fujian coast, rising above the radar horizon in the precise sequenced pattern that the targeting models had predicted would be used to maximize the probability of at least one penetration through the defensive engagement envelope. The Hawkeye crew transmitted the alert in the same second. The CIC aboard the Reagan received it and began engagement sequencing before the initial launch bloom had cleared the atmosphere. The problem was not detection. The problem was geometry. 6 maneuvering re-entry vehicles, inbound from 6 different launch points, on 6 overlapping but non-identical trajectories, with terminal phase maneuver capability that the engagement sequencing software had been updated 3 times in the preceding 18 months to account for, but which still produced intercept probability estimates that the tactical action officer aboard the escort cruiser found when he reviewed them later to be systematically overconfident. The software assumed a maneuver envelope. The actual weapons had a maneuver envelope that was wider than the intelligence community's current estimate by a factor that the engineers in Beijing had been careful not to advertise. The SM-3 Block IB interceptors launched cleanly, 9 of them in a firing sequence that depleted the lead cruiser's ready magazine to 30%. 5 intercepts were clean. The 6th interceptor missed its target by a margin that the post-engagement analysis would identify as the direct result of a terminal maneuver executed at an acceleration rate outside the weapon's seeker tracking parameters. The 6th re-entry vehicle completed its terminal maneuver at an altitude of 41,000 feet and began its final descent. At 2:57 a.m., the Phalanx CIWS on the Reagan's starboard sponson engaged the incoming re-entry vehicle at a range of 2 nautical miles. The 20mm rounds impacted the vehicle's airframe and disrupted its structural integrity, but the kinetic energy of the re-entry vehicle, a mass traveling at several times the speed of sound in its terminal descent, does not disappear because the airframe is breached. The fragmented vehicle continued downward in a dispersion pattern that the CIWS could not address, because it had already ceased to be a single target. It was now a cloud of high-velocity fragments, some large, some small, all traveling at velocities that made their impact equivalent to shaped charge munitions. 3 major fragments struck the Reagan. The first struck the flight deck at a shallow angle, gouging a furrow through the non-skid surface and the steel deck planking beneath it for a length of 22 meters before deflecting into the sea. The second struck the island superstructure at the base of the forward communications mast, severing 2 antenna assemblies and transmitting a shock load into the superstructure that cracked 2 weld seams in the internal framing. The third, the largest surviving fragment, a dense section of the re-entry vehicle's heat shield weighing approximately 400 kilograms, struck the waterline on the starboard side at a point 20 meters forward of the number 2 elevator. It did not penetrate the main belt armor, but it transferred its kinetic energy into the hull plating at a point directly adjacent to a void space used for fuel ballasting, and the resulting deformation of the plating opened a fracture along a weld seam that ran vertically for 1.4 meters before the structural integrity of the surrounding frames arrested it. 1.4 meters of fractured hull plating at the waterline. At the Reagan's current draft, that fracture was intermittently submerged as the ship moved through the swells of the strait. At 2:58 a.m., seawater began entering the void space at an estimated rate of 300 liters per minute. The flooding alarm in DC Central activated simultaneously with the impact. The watch team in DC Central had been at general quarters since the launch detection at 2:54 a.m. 4 minutes earlier. and the damage control officer was already at his board when the flooding rate began climbing. 300 liters per minute in a void space is manageable. 300 liters per minute in a void space adjacent to aviation fuel storage, in a ship that is simultaneously conducting combat flight operations and managing the aftermath of a kinetic strike that had just removed 2 major communications antennas from the fleet's primary command node in the strait, is a different category of problem. He called for the flooding detail before the rate reading had finished updating on his display. The flight deck situation was simultaneously demanding the attention of every supervisor above him. The CIWS engagement had occurred during active flight operations. 2 F/A-18F Super Hornets had been on final approach when the engagement began, and the pilots had executed wave-offs the moment the proximity alarm sounded. One had diverted to the alert tanker track without incident. The second had experienced a momentary flight control input from the pilot's startle response during the CIWS engagement, a completely human reaction to the sound and vibration of the weapons system firing 40 meters below the cockpit, and had climbed steeply before recovering. The aircraft was safe. The pilot was functional. But the flight deck was now in an unplanned configuration with 2 aircraft in the air that needed to land, a gouged deck surface that the air boss had not yet assessed for safe recovery operations, and a crew of aviation boatswain's mates who were being asked to simultaneously manage deck operations and damage assessment in the same physical space. The air boss made the call to divert both aircraft to the alternate landing site, a land base on the island 60 miles to the northeast that had been pre-designated as the contingency recovery field for exactly this kind of event. The pilots acknowledged. The aircraft diverted. The flight deck went into damage assessment mode, 40 meters below the flight deck and 60 frames aft. The flooding detail reached the void space access hatch at 3:01 a.m. The space was dark, narrow, and now contained water that had risen to knee height on the lead petty officer as he entered. He moved his battle lantern across the fractured weld seam and assessed it with the directness that comes from knowing exactly what you are looking at. The fracture was stable, not growing, not propagating, but it was open to the sea at the bottom of the vertical run, where the hull geometry created a pressure differential that was maintaining the inflow regardless of the ship's motion. A wooden plug would not work here. The geometry of the fracture, narrow at the top, wider at the bottom, running vertically through a curved section of hull plating, required a different approach. He called DC Central and reported the assessment in 12 words. The damage control officer received those 12 words and converted them immediately into a resource allocation problem. The hydraulic hull patch kit from the number 3 damage control locker versus the manual backup system. Against a flooding rate that was climbing and a ship that was still in an active threat environment with a second potential salvo unconfirmed but not excluded. In the flooding detail's favor was the fact that the void space, while adjacent to aviation fuel storage, was separated from that storage by 2 frames of intact structure. The fuel tanks were not breached. The risk was progressive. If the flooding rate continued to climb and the void space lost its structural contribution to the adjacent fuel tank framing, the next failure mode became significantly more serious. The math said, get the kit, get it deployed, get the space sealed, and get it done before the rate crossed the threshold that would require the adjacent spaces to be evacuated as a precaution. The petty officer in the flooding space was already doing that math. He had been doing it since he entered the hatch. He was the kind of sailor that the Navy's damage control training system is designed to produce and only sometimes succeeds in producing. A technician who has internalized the procedures deeply enough that executing them under stress does not require conscious retrieval, who understands the physics of what is happening around him well enough to recognize when the procedure needs to be modified, and who has been in enough difficult spaces in enough difficult conditions to have separated the sensation of fear from the function of performance. The water was at his waist. The battle lantern was wedged against the overhead in the angle that gave the best coverage of the fracture. His hands were moving. The damage control officer heard those 12 words and pulled the laminated emergency reference card for the number 3 damage control locker, which contained the hydraulic hull patch kit, a system of inflatable rubber bladders and steel backing plates designed to be positioned against irregular fractures from the interior of the hull and inflated to seal against the hydrostatic pressure of the sea outside. The kit had been aboard the Reagan for 7 years. It had been exercised in training evolutions twice per deployment cycle. The petty officer who had most recently inspected and certified the kit had done so 8 weeks earlier, during the maintenance availability in Yokosuka. He had documented one minor deficiency. The number 2 inflation hose fitting had slight corrosion on the threaded coupling that had been assessed as within acceptable limits but noted for monitoring. The flooding detail reached the kit at 3:03 a.m. The number 2 inflation hose fitting seized on the first attempt to connect it. The corrosion had progressed beyond the acceptable limit in the 8 weeks since the inspection. Accelerated, the subsequent investigation would determine by the higher than normal humidity levels in the damage control locker resulting from a condensation issue that had been reported 3 times in maintenance documentation and addressed twice with temporary fixes that had not held. The petty officer switched to the manual backup, a mechanical pump-operated version of the same bladder system that required 2 operators and took 4 times as long to deploy but did not depend on the pressurized inflation circuit. He made this decision in the time it took to recognize that the fitting was not going to connect, and he made it without hesitation, which is the product of training that has been repeated until the backup is as natural as the primary. At 3:06 a.m., the flooding rate in the void space had risen to 750 liters per minute. The water level was at the petty officer's waist. The manual bladder system required 11 minutes to deploy correctly. The petty officer had 2 operators, himself and a damage controlman 3rd class, who had been in the Navy for 2 years and 4 months, and who had never been in a flooding space in actual combat. Only in training tanks in Great Lakes, Illinois, where the water was chlorinated and the worst outcome was a failed evolution grade, the petty officer could feel the difference in the way the younger sailor moved. Not panicked, trained beyond panic, but tight, economical in a way that was slightly too economical, slightly too controlled, the physical signature of a person spending cognitive resources on self-management that they needed to be spending on the task. He gave the younger sailor the mechanical pump handle, which required rhythmic physical effort and had a simple, repetitive task structure, and took the bladder positioning himself. Above them in the CIC 3 decks up and 200 frames forward, the electronic picture was rebuilding itself around the damage to the island superstructure. The loss of the 2 communications antennas had degraded the ship's ability to communicate on 3 of her 7 primary circuits. The intelligence officer and the communications officer were working the problem together, rerouting traffic through backup circuits and coordinating with the escort screen to relay communications that the Reagan could no longer handle directly. The 5th and 6th DF-21D re-entry vehicles, the ones that the SM-3 salvo had successfully neutralized, had been part of the same coordinated strike package. The question that the strike group commander was already asking, and that the intelligence team was already trying to answer, was whether the 6-round salvo was the complete attack or the opening sequence of a larger engagement. The answer arrived at 3:08 a.m., when the E-2D Hawkeye reported a second set of launch signatures. Not 6 this time, 4. But the trajectories were different. Lower, flatter, consistent with the DF-26 intermediate-range ballistic missile variant that the PLA had been developing as a complement to the DF-21D. The DF-26 carried a larger warhead. Its terminal maneuver capability was less precise than the DF-21D, but its warhead mass more than compensated for the precision deficit at the ranges involved in this engagement. The strike group commander had 90 seconds to decide whether to maneuver the group, a course change that would complicate the ongoing damage control operation but improve the engagement geometry for the escort screen. or hold position and let the defensive systems work from their current configuration. He ordered the course change. The Reagan came to a new heading at 3:09 a.m., her turns increasing as the helm answered. In the void space below the waterline, the flooding detail felt the ship heel into the turn and compensated their footing without instruction, their bodies adapting to the changed angle the way bodies do when they have been living on a ship long enough that the movement of the deck has become part of their sensory background. The petty officer had the bladder in position. The younger sailor was on the pump. The seal was not yet complete. The DF-26 intercept sequence began at 3:10 a.m. The escort screen committed its remaining SM-3 inventory against the 4 incoming tracks, supplemented by SM-6 missiles using their terminal ballistic defense mode, a capability that had been added to the weapon in a software update 2 deployments earlier and had been exercised in simulation but never in actual combat. All 4 tracks were engaged. 3 intercepts were confirmed successful. The 4th SM-6 experienced a seeker malfunction in its terminal phase and flew past its target, and the DF-26 re-entry vehicle completed its descent toward the carrier group. The ESSM battery on the starboard escort destroyer engaged at terminal range. 2 missiles. The first intercept was clean. The re-entry vehicle was neutralized at 400 meters altitude, its remaining velocity carrying the fragmented airframe into the sea 2 kilometers from the Reagan's hull. In the void space at 3:11 a.m., the hydraulic bladder sealed against the hull fracture. The flooding rate dropped from 750 liters per minute to 40, then to 12, then to a seep. Water moving through microporosity in the bladder material that the laws of hydrostatics made inevitable, but that the damage control system was designed to manage with portable submersible pumps that were already being rigged by the secondary flooding team working in the adjacent frame bay. The void space was under control. At 3:14 a.m., DC Central reported the flooding contained. The announcement went over the ship's internal communication system in the same flat factual tone as every other report that night. Not triumphant, not relieved, simply informative. The crew who heard it absorbed it and continued their work, because the flight deck still needed damage assessment, the communication circuit still needed rebuilding, the escort screen was managing magazine states that were now critically low, and the E-2D Hawkeye was still airborne over the strait, its radar painting a picture of a coast that had gone very quiet in the past 3 minutes, in a way that felt less like de-escalation and more like recalculation. At 5:30 a.m., with the flooding detail securing their equipment and the flight deck cleared for limited recovery operations, the strike group commander received a flash message from the fleet commander. The group would be reinforced within 6 hours by 2 additional destroyers and a submarine already transiting at best speed. The Reagan would remain in the strait. The signal would continue to be transmitted. Here are the numbers as the morning watch comes on. 6 DF-21D re-entry vehicles in the first salvo. 4 DF-26 missiles in the second. 9 SM-3 interceptors expended in the first engagement. 1 re-entry vehicle that defeated the intercept. 3 fragment impacts on the hull. 1.4 meters of fractured hull plating at the waterline. 11 minutes to deploy the manual bladder seal. 1 corroded fitting that forced the switch to backup procedures. 2 communications antennas lost. 0 fatal outcomes among the crew. 5,400 sailors who held the strait through 2 ballistic salvos in a flooded void space and came out the other side still operational, still on station, still transmitting the signal they had been sent to transmit. The PLA planners had spent 20 years designing a weapon to remove a carrier from a contested strait. They had hit the ship. They had fractured the hull. They had degraded communications and disrupted flight operations. And the ship was still there at first light, conducting damage assessment with the calm efficiency of a crew that had already absorbed the worst the weapon could deliver and found it insufficient. A warship does not hold a strait because it is invulnerable. It holds the strait because the crew inside it has decided at a level below conscious thought that the mission does not end because the ship is damaged. It ends only when the ship can no longer complete it. The Reagan was still completing it.